Okay, another video. Another video. Okay, so now we're going to stick with our old friend, our surd, and we're going to start to rationalise some denominators. So, what's the point in this? And this is the question that I get every year. Why are we doing this? Officially, if we've got a fraction whose denominator contains a surd, it's more awkward to deal with than when the surd's on the numerator. And I'm going to show you two techniques really today to enable these to be more ease of use, I suppose, moving forward. The other thing really, we do it because it's kind of etiquette and it's just traditionally the way things are done. It's kind of like your table manners. So let's think about our surd and think about rationalising the denominator. So if we've got a simple fraction and we might have, let's go blue. Let's go for this, the first one. So we'll call this first one, we'll have it 3 divided by root 2. Effectively, what we're saying here is that we don't want a surd on the bottom of this fraction here. So I need to think about how I can manipulate this fraction in order for me to get rid of this square root of 2 that I've got on the bottom. Now, the only thing I can multiply square root of root 2 by in order to rationalise it would be another root 2, because root 2 we know multiplies with root 2 to make 2. So what I'm going to have to do is I'm going to have to multiply this by root 2. Now, in order for me not to change the value, the numerical value of this fraction, this 3 over root 2, I'm going to have to multiply it by a fraction that is effectively root 2 over root 2. Okay, now we're not changing the value of the fraction, but what I'm going to crucially do, when we multiply across the bottom here, we're going to do root 2 times root 2, and that's going to get rid of the surd from the denominator of this fraction. So what does this equal? Well, 3 times root 2 on the top, that's 3 root 2. And divided by root 2 times root 2, which we've already said would become a whole number 2. So it's 3 root 2 over 2, or 3 over 2 root 2. You can describe it in different ways, but that's the first rule that we're going to have to do in order to rationalise our denominator. And what we need to ensure we do whenever we're doing these is we look at whatever the surd is on the bottom and we multiply the numerator and the denominator by whatever that surd is on the bottom, root 2 over root 2, and it gives us our final answer here. Okay, so the second type of thing that we're going to be asked to rationalise will look something like this, and it will be something like, let's just have a nice number on top, 5, and that's going to be divided by 5 plus root 2. Okay, now this one's conceptually a little bit trickier to kind of get your head around in terms of what we're doing and why we're doing it. Essentially though, the same thing is occurring. We've got this surd on the denominator and we need to multiply this fraction by something in order to get rid of this surd. Now, the only way that we can do that is by using the idea of the difference of two squares. And we need to think about how two brackets will multiply out in order to manipulate that situation. So let's just go across to one side, as we sometimes do, and think about what's going to happen. Now, what we've got is effectively, what have I got, a plus? So what we've got is some number p plus square root of another number q. And we're going to take that and we need to multiply it by something that's going to get rid of the surd. Now, if we think about the opposite way of the difference of two squares, we're kind of looking at the final factorised scenario of the difference of two squares. What we'd have p plus root q, and it would then be p minus root q. And what's important about this is the minus sign that I've put in here. So we had a plus originally, I need to put a minus. If we started with a minus, I would then change this one into a plus. But as long as we've got one of each, this difference of two squares is going to occur. Now, we're just going to expand our brackets just like we always have done in our GCSEs, and we can make a nice smiley face just to make sure we remember to multiply everything out. This might be quite distracting if you're not used to this method, but effectively what I'm going to do is I'm going to do p times p, root q times minus root q times p, and then p times minus root q, and we'll see what happens. So the first one I said was p times p, we should be left with p squared. Okay, next one, we've got the right eyebrow, we've got root q times minus root q, which, well, we know root q times root q would become q, and because we've got a plus and we've got a minus, it's going to become minus q. So p squared minus q, now, smiley face at the bottom, p times minus root q is going to be minus p root q, and then the final one is going to be the q, root q times p. So there's two positives, this one's going to be plus p root q. And what's quite nice is we've got this minus pq and plus pq, put them together, they're going to have a value of nothing. So they effectively don't have any impact on what we've got. So what we do when we expand this, we get left with a p squared minus q. And we're going to do the same thing when we go back to our problem over here. So let's go back to our original problem. We've got 5 plus root 2 as our denominator. So I need to work out what I need to multiply this by in order to get rid of this root 2 on the bottom. And what I'm going to have to multiply this by would be 5 minus root 2. Okay, so again, similarly to my p's and q's that I was using just now, I had this plus root 2, now I'm going to have it minus root 2. And again, the same as in our first example at the top, in order to not change the value of our fraction, I need to multiply it by the same on the top and the bottom. 5 minus root 2. Okay, now this is going to take a little while, so what I'm going to do is I'm going to go down and I'm just going to kind of push the things together. So, what have we got? On our numerator we've got 5 lots of 5 minus root 2. And in doing that, all I've done is I've pushed this 5 next to this 5 minus root q, because they're multiplied together. Then on the denominator underneath, I've got two brackets. 5 plus root 2, 5 minus root 2. Okay, so it's now a case of expanding, simplifying, and cancelling wherever we might be able to. So, where should we work first? Let's carry on going down, and what I'm going to do first is I'm going to just look at the numerator. I'm going to do 5 times 5 and then 5 times minus root 2. So my numerator now becomes 5 times 5, 25, and then minus 5 root 2's. Okay, similar method to my denominator before. I'm going to use my eyebrows, I'm going to expand all the bracket and go through, and what I should be left with is 5 times 5 giving me the 25. I should be left with the root 2 times minus root 2, which becomes minus 2. Then one of them will give me plus 5 root 2 and minus 5 root 2, which is why the beauty of this, these two now cancel, because 5 root 2, take away 5 root 2, that has no impact on anything at all. So let's simplify a little bit further. A few steps in this. Yeah, I know. What have we got on the top? I'm not going to change this. We've got 25 minus 5 root 2. And on the bottom we've got, well, all we've got is 25 minus 2, which we know is 23. And that is our original fraction rationalised. That is our final answer. let's just have a quick recap. What have we done today? We rationalised two types of fractions, where we had a surd on the numerator, sorry, surd on the denominator. Surd on the denominator here, root 2, we multiplied by root 2 over root 2. This one, a bit trickier because we've got this 5 plus root 2. In this instance, what we need to do, in order to rationalise it and get rid of it, we need to use the properties of the difference of two squares. And we're going to say 5 plus root 2, we multiply it by 5 minus root 2. Both instances, we've got to make sure we multiply it by the same on top and bottom, so that we're not changing the value of the fraction. And then here it's just a case of expanding brackets, simplifying, cancelling down where appropriate. Now, what might have been a good idea is actually not to have expanded this, and you didn't have to, or I didn't have to expand across here, because what I might have been able to do is simplify this slightly by cancelling the 5 with something. In fact, when I see it at the end, that 5 wouldn't have cancelled anything, so I didn't lose too much. But you might in your exam be asked to simplify. Okay, and that is as far as we're going to go today on rationalising denominators.